Hello learners, this is Education Online program. I'm here by teacher Rose Hezekiah. I'm presenting for you a lesson in chemistry for senior 1 and 2. Our topic for today is still will continue on separation of mixtures. As I have mentioned in my previous lesson, that there are different ways of separating mixtures. So today we will be looking at how to separate mixture using evaporation, and then how to separate mixture using simple distillation. In both ways, we have a solution of salt. In the first process, or in the first method, we will be separating the salt from, that is the solute, from the solvent. And then in the second, we will be separating the solvent from the solute. So let us look at the first method, that is evaporation. Evaporation, by definition, evaporation can be defined as the process where liquid water is transformed to gaseous state. Then our main aim is separation of a mixture, of common salt. Common salt, that is sodium chloride, and water. Separation of common salt and water. Or we said solution of sodium chloride. Solution of sodium chloride. We need to separate. So we use evaporation. To obtain or to get solute from solvent. So in this solution, our solute is the salt and water is the solvent. We use evaporation to get solute from solvent. We said our solution is solution of sodium chloride. So the solute is salt and water is the solvent. So we want to get salt. From water. Or we said we need to separate salt from water. That is in step number 1. So we are going to separate the salt from water using evaporation. In order for us to carry evaporation process, we need apparatus. So our apparatus here is we have evaporating dish, we have evaporating dish, we have heat, we have water bath, so what we do is we subject, we put a stand, then we introduce our heat, then we have the water in a container, then we put our evaporating dish. Here we are using indirect heating, or we call it steam heat. Here the water will boil. We have water. The water will boil. Then steam will boil there. We have here the solution of salt. We heat the solution of salt indirectly in order for us not to lose some of the salt, because when we introduce this salt solution to heat directly, we will lose part of the salt. So we heat water, and then the water will be the one, the steam will heat the salt solution. So heating the salt solution, water will evaporate. The water will evaporate, or we say the solvent, which is water, the solvent will evaporate. So once the solvent evaporates, we will be left with the salt behind. So in this way, we have already separated the salt, that is the solute, from the solvent. We use evaporating dish, and we heat the solution indirectly, not to lose part of the solute or part of. So the purpose is so that we have slow crystallization. We have slow crystallization of the salt, because when we heat it directly, we will lose part of the salt. So we heat it indirectly in order for the salt to crystallize slowly, so that we don't have overheating. So this is the first method of separation, that is separation of solute from solvent. And we have our solution is solution of sodium chloride, that is solution of salt, common salt, and water. We want to get the salt. We get the salt through evaporation. We heat the salt solution indirectly so that we have slow crystallization. So we heat the water, then the water will warm the solution until the solution boils, and then the solvent, which is water, will evaporate. The solvent, which is water, will evaporate, leaving behind the solute. In the second method, we have what is called simple distillation. In simple distillation, instead of getting the solute, we now need the solvent. In evaporation, we The main focus is to get the salt. But in simple distillation, we need the solvent. So, if we want to separate a mixture of common salt and water, and we need the water instead of the salt, we use simple distillation. And in simple distillation, we have distillation set. So, distillation is a process of purification or separation of the components in a liquid mixture, either purification or separation of components in a liquid mixture. So our liquid mixture is the solution of sodium chloride, and our aim is we need to separate the solvent. We need to separate the solvent, that is water, from the solute. We need to separate the solvent, and our solvent is water. We need water. We need to separate water from the salt. So we use distillation set. Our distillation set looks like this. We have a stand. We have a round bottom flask, and then this is a thermometer is attached to it to control or to measure the temperature. And then we have here heat. Here we have our mixture. We have solution of sodium chloride. Then this flask will be connected to a condenser. This flask will be connected to a condenser. And this condenser is called Labec Condenser. The condenser have got two openings. This is to allow water out, and the other side is to allow water in. This means there is a cycle of water moving. Water will enter through this way, move, and then leave through the other way. And this water is to cool, make a cooling system. Then at the end of the condenser, we have our distillate. We call it, this is called distillate. We put a conical flask. We fix a conical flask here. The distillate will come in form of a drop. So we have, this is the distillate, or the solvent that we are in need of. So we have, this is called distilling flask or round bottom flask. Distilling flask. So what happens is that the solution of sodium chloride will be heated. When it is heated, water will boil. Of course, we know that water boils at 100 degrees Celsius. So once the water boils, it will turn into steam, that is gas. Then it will leave the flask through this opening to the condenser. The work of the condenser is to condense the liquid, the gas, sorry. To condense the gas. And the condenser condenses the gas through the cooling system. That is the movement of water in and out. So water in is the cold water and water out is the hot water. So the movement of water will continue until all the distillate is collected. So, and this solution here will continue to boil until all the water evaporates, leaving behind the solute, that is the salt. So the solution of sodium chloride, that is salt solution, will be heated. The water will boil fast because water boils at 100, and this boiling point will be detected by the thermometer that is fixed at the upper end of the flask. Once the water boils, it changes into gas, that is steam. The steam will move through the condenser, and then the condenser will condense the steam, and then the steam will turn into liquid again. So it will, at the end of the condenser, droplets of liquid will fall from the condenser and then collected in this conical flask. So what is collected in the conical flask after distillation is called distillate. So the process will continue until all the solvent evaporates from the solution, leaving the salt behind. So in this process, we will be able, or at the end, we will get our solvent, that is the water, and then leaving the salt behind. So at the end, we can separate the solvent, that is water, from the salt, that is sodium chloride. So this is a brief explanation. So we say that this simple distillation is a process used for separating solute, is a process used to separate solvent from a solute based on the principle of boiling point. So water boils, the water changes to steam, the steam is condensed in the condenser, it changes to liquid, and then the liquid will be collected. And the liquid collected is called the distillate. And then in evaporation, the aim of evaporation is to get the solute, that is the salt, from the water. So we boil the solution in an open container so that the water evaporates into the space, leaving behind the solvent. So these are two different procedures or two different methods of separation of mixtures with two different aims. We said in the evaporation process, we need to get the solute, that is the salt. And then in simple distillation, we need the solvent. So we need the solvent, that's why the separation is done in a closed system so that water doesn't evaporate into the space. So, dear learners, we have come to the end of our lesson. Thank you. See you in the next lesson.